assignment, you were asked to set up an environment, also to verify that the environment was working. You were asked to create a really simple hello world controller, map it to a couple of URLs, and expose a really simple hello world data model. All right? So let's do that ourselves so that we can demo. There were a couple of questions that some folks were having, so I just want to go over those. Let's see, where are we? It's web dev, Spring. Okay, so let's go into 4500. Let's go in 2009, section 2. And in here, we'll create the Spring Boot application and create the controller, and we'll talk a little bit about that technology. Each week, we'll incrementally add to a particular skill. The skill of this week is exposing data to a URL. Right, that's a very generic skill to have. Being able to map a particular URL and execute some code in the back end to do some work for us and respond with some data back. Okay, that's a very, very common skill that we need. There are many styles of how to do that. The particular style that we're concerned in this particular circumstance is to have the RESTful style. Okay, and we'll explain a little further why is it RESTful. Not until we have an actual data model. Meaningful data model would REST really mean anything just yet. Right now it's just being able to map a URL to some data. Okay, so let's create the application that we are showing here. In the course material, I provided some for this week. I provided some pointers on how to do that. A little later in Spring Boot and Heroku, kind of walks you through doing these steps. Although a lot of you are already done, so it's awesome that you're looking ahead. So let's create our Spring Boot application, and we'll call it. So this is CS 4500, Spring 19. What's the name that I suggested? Section 2. Well, I'm already in section 2, so I'm not going to use section 2 here. Actually, I need it because then I'm going to push this to GitHub, right? So I need to be able to distinguish between the two sections. And I'm going to use my CCIS username. So that's going to go on and create a template for me. If we go in there, it's a little bit low. Did it create it? Okay, so let's go in there. We can now create a really simple web page very quickly. We can say let's first create a directory in sources in main, and we'll call it web app. And in there, we're going to put our index page. This is going to be the landing page of our web application, right? Of our website. So we'll do cat into source main. Web app, and I'll put it in index HTML in there. And for now, we'll just say h1, welcome to CS 4500. Right? As servers go, typically servers, their responsibility is to listen forever at a particular port number for incoming HTTP requests, and then parse the requests that come into that port and map the path that comes into that request mapped into a physical directory and file. Right now, the root of that directory from where the files are being hosted is the web app directory. Right? It's a standard name in the Spring Boot world. Other servers use public or home or whatever those server you might be using. But here's a web app. All right, so we created our little index, and we're ready to build this. So Maven clean install. So this is going to compile, package, and deploy locally on our local machine. And we can then run it by running the jar file that was compiled and packaged inside of target. So that target directory wasn't there before. Now it's there. We can run it. We can see the content. There's a jar file that gets built, right? That's based off of the name of the project that we created. So we can say java.jar, and then say target, and then cs. There we go. This boots up the server. In this case, it's a Tomcat server, and it didn't work. What? Listen. Okay. Apparently, I might have something already running at 8080. Maybe this one's running? Yeah, it is. So let's try it again. Okay, so it looks like it started Tomcat and listening at port 8080. We can then navigate to our hello world, really simple, localhost 8080. And there's our welcome to CS 4500. Notice that it's really loading the index.html document, but if you don't provide it, it just assumes that's the file that you want, right? So index.html is a special name, right? It's a file that has it's a default file that gets sent over if you don't specify which particular file you want. All right, so that's one of the skills that the assignment asks you to become familiar. The other skill that it asks you to do is to learn about how to expose data. Right? We're going to need to learn how to do that since we're going to have data in some database. We're going to need some way for the front end to get a hold of that data. So the intermediate step to do that is to put a middle tier kind of application in the middle that listens to incoming requests from some client and then translates that to some data access to a database and then spits it back out to the client. So that's a skill that we need to become familiar with. So to do that, I'm going to use we can use STS or if you prefer to use IntelliJ, that's fine. I'm going to import, and so it's going to be an existing Maven project. It's a Maven project. You know it's a Maven project if it has a pom.xml in that directory, in the root directory. So indeed, ours does have a pom file, right? So if you say, notice that we have the pom.xml, right? That was created for us. Notice that we did create the index file in there, right? But we kind of forgot what I was suggesting, right? That all work should be done in a particular branch, right? And notice if we say git status, this is not even a Git repository, right? So I kind of started working, already breaking my own rule. So let's initialize this to be a repository. I know I added that one file, the index file. So let's initialize this to as a repository. It did create it. Notice that we know it's not a Git repository because there is no .git, right? But now there is a .git in there, and now we know that this is indeed a valid Git repository. Source control, you know, if you're working just on your own, it certainly is very useful so that you can keep track of versions of what you're doing. But it's essential when you start working with teams. Right? It's going to be our main way of being able to interact with other folks. You know, source code that you're working and source code that I'm working, and at some point needs to be merged together, right? Make sure that we don't step on each other's toes, right? That you're working on a particular feature, I'm working on another feature. So Git source control is definitely very, very important. Anyway, so let's see. Git status. Git status tells us, are there any files that I'm not keeping track of? What's going on, right? So you're going to be using Git status quite a bit. It's telling us that there's a whole bunch of files here that it doesn't know anything about, right? It says, I don't know, what are all these files? So we need to determine what to do with them. Typically, we're just going to add it to the repository because we want to keep track of source. And source, we mean source, right? We mean that no jar files, no compiled files, no .class, right? No .bin. Any libraries should not go into source control, right? Source control is only for source. Right, we want to maintain only the source code. So let's see. .git ignore, that's source. Command, it's source. Pom is source. If it's under source, it's source. Let's see what's under .maven. .maven. Let's see. There's a wrapper. So there's a jar file in there. Probably we don't want that jar file. Probably we don't want those properties either. So there's certain files that perhaps we don't want to keep track of. Okay. Let's see. Notice that that it wants to keep track of everything, right? But we certainly want to make sure that we only keep track of what we need to keep track of. For instance, if there are any files that are specific to your IDE, right? Maybe we don't want that because you have you're using Eclipse and somebody else is using IntelliJ, right? So those are files that are specific to your particular environment. That shouldn't go into your environment, into source repository. So there's lots of files that we might want to ignore, and there's a file there that we can use to ignore certain files or directories. So let's look at what's inside of .gitignore. Already it has certain things that we know we're going to want to ignore, right? So for instance, files that are specific to the STS IDE, such as .classpath, .project, .settings, those are specific to STS. It knows that IntelliJ creates all these other files. So we already have a working .ignore file, which is pretty good already. Okay. Plus, it knows that there's a whole bunch of build directories that we want to ignore, and we probably want to ignore also this .maven. So let's add that to that file. We can change it .gitignore. And we'll add .maven in there. So let's .maven. So if we do a git status again, notice that the .maven is ignored now. Right? So it's not being added anymore. Okay. All right. So yes, these are the files that we want to keep track of. And as I had suggested earlier, this is my very first commit. And so let's do that. Perhaps let's do our work in a particular branch. Right? So let's do that. So let's create a branch. So right now we can take a look at what branch we're in. We don't have a branch. We haven't committed anything. So let's do a git add. So git add allows you to put the files in what is called staging. So meaning I'm suggesting that these are the files that I want to make permanent into source control. I'm going to add all of them. I'm going to say git add dot, especially if you have created 2, 3, 4 files. There's an easy way to add all the files. Or if you just want to do it one at a time, you can say git add and then the file that you want to add. Right? So I'm going to just add all of them. And we can ask git status. So now these files are what is called, they're in staging. They're ready to be committed into source control. And again, we can commit one at a time. So we'll do that. We'll say, okay, well, I'm happy with all these files. I've tested it locally. It works, right? My website comes up. And so I'm going to do a commit. Oh, wait. Git commit. And then this is my very first commit. Git status. So I've committed it. Notice that the command was git commit dash AM. So typically I would only use M. M meaning I'm going to provide a message, right? Some comment, kind of summarizing a bit what is that I've done in this particular commit, right? And it's good practice to have these commits be very verbose. Maybe not every line of code that you add, but once you feel comfortable and have reached a particular phase of development where your application is at a stable state, right? It's a good idea to commit, right? For instance, maybe and the granularity might be different, from one developer to the next, or how complex it is that you're working on. It might be a very simple method, and maybe you decide that you implement the method and you commit that. But if the method is a little more complex, where several if statements and several branches and several loops, perhaps every time you reach a level of complexity that you want to make sure you don't forget, it's a good idea to commit. All right. So the level of granularity might be different from one developer to the next and whatnot. All right. So now we have the master branch. This is the master branch. The master branch, as the name suggests, is the most important branch. It's what we consider to be deliverable. It's what we consider to be what has deployed and what the actual client is looking at, right? It's the code that is actually running on the system, right? So we certainly don't want to screw around too much with master if we want to break something. So typically what we do when we're working on a particular feature, we create a feature branch, right? So we might say git branch, let's say we're going to work on the feature of adding our dummy hello world controller here. So let's add this really simple hello controller. So let's do that. So we'll do a branch and we'll call it hello controller. Okay, so that creates the branch, and so we now can say git. We can list the branches. Git branch. Notice that it still says that right next to it, the star means that this is my current branch. That's the current branch that I'm in. I just created hello-controller as my other branch, my feature branch, and I'm gonna switch to that branch. So I can say git checkout hello controller branch. All right, so now we can say git branch again, and now we are in the hello controller branch. Any work we do will not be on the master branch. Will be on this branch. All right, excellent. So let's do this. Let's create the controller. Let's create the controller. Oh, did I? I don't believe I imported it. Let's import it into our IDE, and it's let's see, where is it? So it's Genunzi CS 2019 section 2, and there it is. This is my project. So I'm going to open it up. It's this one right here, and in here, notice that there's some default files that were created for us. Let me close these. Course about yeah, don't save anything. Go away. No. Close all. Okay. So all right. So a couple of things here on some of the default files that were created for you in the Spring Boot project that were created. Notice that what it did is that it came up with this weird package name com.example. And then that's the name of the project that we chose, right? It removed the dashes, and it creates this demo application file. This is the entry point to the application. It's just a main file. This is what gets executed when you run it at the command line, right? This is what gets executed. Also, this package is very important, right? It's what we refer to as the root package, Java package. And any controllers, any repositories, many of the files that we're going to be creating, right? They only work magically. They work if you create your files under this particular default package. Right? If you want to create it in a separate package, there's some extra work that you need to do, okay, which I don't want to get into just yet. So the easiest thing is to create your controllers and your data models and your and your repositories under this particular directory. So let's do that. We're going to create a new class, and we'll call it the hello controller. So hello controller, and notice that it is indeed created under that default package. You see that? Under there, I can create my own packages, right? So I might say that this is a controller. Okay, I can put all my controllers under there. And there it is. So it creates my controller under there. Right. Okay. If you don't like that package, you want to put it elsewhere, you can, but there's more configuration that you need to do. Right? So the easiest thing is to just put it under there. Okay, so under here, we can just copy some of this source code. So this is a REST controller. This is a REST controller. This @ that we put in front of this token here. It's using a very popular style of programming that has become very pervasive everywhere. It's what we refer to as aspect-oriented programming. just like this object-oriented programming, this component-oriented programming, there's aspect-oriented programming, meaning you can invoke certain behaviors just by invoking some of these tokens. There's obviously this code behind this aspect, the REST controller, and the behavior that is being injected here is that I'm going to be able to expose certain functions here. So a method here that I might say hello. Right, so I'm going to be able to expose this this function, expose it as a URL. Or that's the behavior that is being added to this class. Right? Not only can I just call this from some other classes, right, by instantiating this class and invoking this function and returning a string, but because I am decorating, this is called decorating a class. I'm decorating this class as a REST controller. I can invoke certain behaviors, and the behavior is that I will be able to not only call this locally from other classes, I can call it from a URL, so from somewhere in the internet, on the web, right? And the way you do that is by decorating the function. And we can decorate it by saying that I want to be able to access this through an HTTP request through the web, through a GET mapping, and I'm going to map this to API hello. Oop. Meaning, if the server, when it's running, sees this URL pattern, if it sees that in the URL pattern, it will execute this function. Right? So this is one of the easiest ways to very quickly expose data, right, at a URL. Right now it's just a simple string. All right, so we're pretty much done here. Let's try it out. Let's compile again. Say Maven clean install. That will recompile, will repackage, will redeploy. It'll create a new jar. We'll overwrite the old jar file, create a brand new jar file, and we can just run it again. So Java -jar target and CS. There it is. Oops. There's no JAT. It's a jar. So that runs, and we can try and hit it again. So localhost. This index file is still there. That doesn't change the fact, but I can now. I've created a brand new URL, API/hello, which returns the hello world string that we're exposed. Make sense? All right. All right. So this is a good chance. This is a good place to say that we have a working example on how to say hello at a URL. We can do a git status, see how far we've gotten. It looks like we added this directory, which has my new control. So let's git add and git status again. So we're ready for that hello controller to be committed, right? It's a nice stable place where we can put a stake and know that we've reached a particular milestone. So we'll commit. So git, just always make sure you're in the right branch, that you're not in master. Right? Make sure that you're not in master. Do all your work in a feature branch. Ideally, you would then provide it to someone else to take a look at. And they might say, "Yeah, I like that," and then they would merge it back into master at some later time. All right, so we're going to git commit added say hello controller. These are meant to be very short messages, right? That capture the essence of what it is that you did, right? So that's why your work should be so simple, right? That you should be able to explain it in just in a heading. If you're going to have several lines of explanation of what is it that your commit does, is that because then your commit is too big. You did too much work between one commit and the other commit. Right? These are meant to be really, really short. That it might, if I introduce some bug or if there's some issue that used to work but no longer it's working, I should be able to just backtrack my way to a previous commit, right, and go back to a safe place where I know it was stable. All right, we did that. Let's go on and do another demo. Let's now create an object, and let's we'll call it class, and this will be a hello under another package. So this will be models. Models, it's going to be a package where we put just data, things that we want to model, data models, right, of users, of services, of a relationship between data, anything that has to do with me capturing any data whatsoever, right? In this case, we're going to have a trivial hello object. But other examples of other data models that we might have in here is maybe a user, right? Maybe a user. And a user might have things such as private string. If I could spell, we could have maybe a username. You might have password in here. You might have a string. I can't type. Jeez. My first name and whatever, right? Plus any setters and getters that would go along with this. Right, and so this is my data model, right? Presumably this Java class, presumably is mapped against some table in the database, right? And each instance of user in memory maps to some record or some row in some user table, right? We'll do that maybe next week or the week after that. But for now, let's do something trivial, something way too easy. So here's my hello object, and instead of having so many attributes, we'll have just a trivial attribute, and will be just a string and a message. All right, and setters and getters, we'll add a setter and a getter for the message. Okay, everybody good? All right, excellent. So we have data. So the hello controller. Maybe that's a good place to put a stake and say, oh, we added these data models. Yes, let's do that. We can say git status. It says that it looks like you added a couple of a new directory with several files in there. We'll do git add both of them. Git status. Looks like there's two files. Maybe we should commit each one individually, especially if we had made lots of work on each one of them. So we can commit each one individual. So we say git commit with a message saying added user data model, and then just commit that one single file. So we just committed that one file. We still need to commit the other one, right? The hello object. We might have made several dozen lines of code in there. We didn't, right? It's just trivial, but again, this is easy enough that it's good for concepts. So git commit the hello world. So added hello object data model, and with this file here, and we can look at the log of what have we been doing, right? We added the hello, we added the user data model, we added the say hello controller and whatnot, right? So we can always have a list and if we paint ourselves into a corner and somehow it's no longer working, what used to work, like we can go back in time, right, and go back to a previous place that we knew it was working, right? But if you commit so many files or so many changes, then it'll be much harder, right, to backtrack to a safe place in your history. Yes, so that's why it's a good practice to be very verbose. Lots and lots of commits, small commits, right? And the assignments are going to ask you to do that, right? And you will be graded on that. Right? So make sure that you keep your commits small. All right, excellent. So we did that. Let's now go over to the controller and expose that new data model. So we'll say get mapping, and this will be /API /hello and /object. And this will be public. So the skill here that we're learning now is that not only can you return just a simple string, right, which is somewhat lame, but you can also return full objects, right? You can say, we can return a hello object. So this would be get hello object, right? And we're going to say we're going to build a new hello object, new hello object. And we're going to populate it, so hello dot set message hello world object. And we're going to return the hello. All right? Okay, excellent. Let's stop the server. We'll need to recompile it and rebuild it, or we can run it from your STS or from your IntelliJ. By running the demo application.java, we can run that as a Java application. So this will do the same thing as you would do at the command line, but now maybe you could put breakpoints, you can step through it, you can debug the problems if you run into an issue. So that's hopefully it's compiling, maybe? Yes? No? Are you? Oh, there it is. All right, so it's I believe it's completed. Let's refresh. There's our hello or our hello object. So okay, notice that it's coming back as data, right? As opposed to just being a string. It by default it converts it into what is called a JSON object, right? A JavaScript object with name value pairs. The names of the fields are based off of the names of the fields that we chose on the data model. So hello object has a field called message, right? And that's why the properties message. And the value is whatever we set it to be. So instances of objects. Everybody okay? Right. Right. So those are the skills that this week is showing you. Every week we'll add to that skill set. Right. For instance, next week in the next assignment, it'll ask you to set up a really simple front end. Right. The front end. Eventually, what the front end is going to do is going to ask for this data. Right. So it'll ask for users. So you can display a list of users that will allow you to maybe remove a user, add a user, edit a user, and whatnot. Yes? Okay. Again, the course doesn't focus on these skills, evaluating these skills. We're going to give you all this source code, so that you can focus more on the engineering part. Yes. Yes, of course. Yep. Yeah. Let's just we can demo that real quick. So, for instance, this might be. Let's copy that, and this might be say parameter, and then you can put a placeholder here, right? So this is some message, right? And say hello object parameter, and then we can map here that I want the message here. Right, I want to receive it as an argument, so we can tell it to please parse the URL, and extract that parameter at the end. Right, so we can say map this to the path variable called some message, and then once you parse it out, give it to me as an argument, as a parameter to this method. Path variable, and then here I can now set that this is the message that came through. Yes? So let's try that out. Let's restart. Uh-oh. Oh, thank you. Sorry. Stop. Let's restart. It's done. So this one still does the same thing. Or we can say parameter and say life is good. So it takes that, parses it, right, and then returns whatever you sent over. You can have path parameters or query parameters, and we'll talk about when to use one or the other, right? And again, it's just the REST style of building these URLs. These URLs it's not anything you want. It follows a particular syntax, right? We'll get to that a little later. Everybody good? All right. So we are at a particular a stable status of what we've been working on. We can look at what we've done so far. It looks like this highlights what we've changed so far. It looks like we added a path variable, we added the hello object, we added the get hello object and get hello object parameter. Ideally, I would have committed when I had finished my hello object function method, right? And then committed again in my second when I created my hello object parameter. So again, these are too trivial to make any difference, right? But when you start actually working in your projects, ideally these will be complex enough, right, that you would either commit every method or maybe several times per method, right, depending how complex your actual method is, right? Okay. All right, I'm just going to remove that that extra space in there. All right, so I'm gonna commit this and say git commit, and this will be added get hello object and parameter. All right, so it's been committed. Git status. There's nothing to commit. We're clean. We're going to git push. Now push is going to want to send it to a remote repository. Right? I believe the assignment asks you to create a repository. This one's going to complain saying there's no place for me to send it. You only have the local repository. Right? Actually, we can look at are there any remotes? There are none. Right? There's nowhere. Everything's local. Right? Everything's being put under the .git. All of my changes are local in my local repository, which lives under .git. Okay. We're going to declare a remote repository, right? That's going to look identical to mine that is here, and that one, as a team, we're going to share that remote repository, right? So that we can, I push code and you push code, and then I pull your code and I merge it into mine, right? So we can collaborate. So let's do that. We're going to go to GitHub in Janunzi. And we'll create a repository. The repository, I'm going to call it the same name as my project. So repository, I'm going to say new. Oops. Paste, there it is. So it's going to create that repository. It's a brand new repository. This gives me kind of like a cheat sheet on what to do in my local repository to push all my content to this remote repository. So we've already initialized our repository, so I'm going to skip that. We've already added files to my repository, so we're going to skip that. But here we're going to add we're going to add this repository as our remote repository. So I'm going to copy that. In my local repository, I'm going to say git remote add origin. Right, so notice the origin down there. Okay, and so what this means is that origin is a special name in Git. It means that this is going to be my default remote repository. I can have many remote repositories. Right? I can push my code to one repository. I can push my code to another repository. Yes, but typically we declared one particular repository as the default. This is the one that we're all going to be sharing together. Right? So that's the name. Right? So git remote add the default repository, and then that's the actual remote one, right? GitHub.com, Janunzi, CS4500, yada, 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 right? So I've added it. Notice that if we do a git remote, now it lists origin there, see that, as my remote repository. If I want to know more information about repository, I can say -v, meaning verbose, meaning that if I push code to this repository, that's where it's going to go. And I can pull code also. I can fetch code from this remote repository, and it'll be copied off of that remote repository. Okay? And so when you create teams in the next week or so, right? All 9 folks in one organization, you're gonna clone, right, the same remote repository onto your local machines, right? And then each one's gonna work independently, right, on your particular feature, and then you're all gonna send to this remote repository for someone else to review your code and accept your code as a team. Yes? Right? Not yet. In a week or so. All right. So we're ready to push. I can now push my content. It says, okay, well, you're not pushing to master, right? You're not pushing to master because you're not in the master. So it's telling me you're not in the master branch, so you must want to push this branch to the remote repository, maybe for some other teammate to look it over. So let's do that. We can push to the hello controller branch. If we go to Git, and we do a refresh, notice that nothing has been pushed just yet. So let's copy and paste. I'm going to push. It's going to copy all that content over. If we refresh now, notice that we have code in here. See this? Right? We have code in here. Also, we have, let's see, branches. We have the master branch, plus we have this hello controller branch that has all the code, right? We have a whole bunch of stuff in here. We have the main. We have the controllers in here, right? We have the 2 models that we created earlier, right? All the source code is there. But if we go to the repository, what you see here, if I go to main, wait, did we merge this? Oh, we didn't. Okay, all right. I skipped creating a pull request. I'm sorry. Typically, you would create a pull request, right, off of a branch and assign it to some other teammate. They would look over your code, right, and then accept it. Right. We'll do that next week. Right. That'll be part of the assignment next week. We'll create a pull request. I'm sorry.
How can you push master until you push the little branch?
Oh, I didn't. That's right. Git status. Oh, okay. Yeah. Git branch. Git checkout master. Git push. Oh, yes, I didn't push master. I'm sorry. Yep, let's do that. Okay, so if we go back here and we look at our branch. Okay, there we go. So we have two branches now. We have the master branch and the hello controller branch. And in our source code here, right, we have all the code. Typically, we would have done the pull request, right? So we skipped over that part. Although it doesn't make sense until you actually have a teammate, we still want to practice that, right? So we'll in the assignment next week, we'll ask you to practice that just on your own, just by yourself, even though you're not part of a team. What we'll ask you to do is to ask one of the TAs to assign the pull request to a TA. The TA will accept your code and it'll merge it into master, right? So you get a chance to practice this on your own with the TA. When you join a team, then you'll get a chance to do it with the rest of your team. Okay. All right. So one of the deliverables for this week is that you need to copy that URL and send it as on Blackboard. So copy that URL and make it available. Also, one of the things that you need to do is invite folks as collaborators. Oh. So as a collaborator, then you'll ask other folks to join you as collaborators. Yes?
For this part, the TAs, email
Oh, it didn't work?
Yeah, it's
Okay.
one of the TAs wasn't a collaborator.
Okay. All right, yeah, so post that as a public issue that we need to look at on Piazza, and we'll certainly make sure to. Yes, please. So typically you would type in the username. Maybe not. I don't know. I don't think the email. It's just the username, perhaps. In this case, Giannuzzi. So here I would be adding myself as a collaborator. Yes.
All the TAs' GitHub usernames are on the syllabus. You can use the username inside the email.
Oh, and that worked?
Yeah, it'll work. And it's on
Okay. Okay. Yeah. So the syllabus should have them. As the yes.
Are you using our personal GitHub or
If so, I'm not sure if the CCIS GitHub allows adding collaborators. Does anybody try that? Does the CCIS GitHub allow collaborators? It does? Okay, so if it allows collaborators, then you can use the CCIS. Yes?
My experience is it only allows collaborators. I haven't used it for a couple of years, but only allows collaborators who are also using this.
The CCIS? Oh, okay. All right, so we have to make sure that you're in the same. Yes? Yes, please keep them private. And I believe all the CCIS ones are private by default. Yeah, okay. And the GitHub.com, I think by default they're public, but you can make them private, and it's free if you're a student. You can create, or maybe they change it so that you can have any number of private now. Is that right? Okay. Yeah. All right, excellent. So that's one of the deliverables this week, right? That this URL that you've invited everyone as a collaborator. The other thing that we're asking you to do is to please host this on a server, on a Heroku server. Okay. You should have installed the Heroku CLI, created an account in Heroku, logged in. I'm not going to try log into Heroku. But we're going to push it to a Heroku application, so we can do, let me look at my cheat sheet. Let's see, Maven. Yeah, so Heroku login, then Heroku create. So what Heroku create is going to do is it's going to parse the application. It's going to look at the root directory, and it's going to figure out what type of application this is, right? So it realizes that this is a POM project, right? So it already knows that it must be a Java application, right? It also looks at the dependencies in POM, so it knows that it's going to have to download certain libraries and whatnot. So it figures out that it's the correct application type. If this were a Node.js server or Python or whatever other, or PHP, it would have figured out the type of application, so it knows what type of server to install for you, okay? But here it figured out that it's a Java application. And also, it declares a random name for your application. So ours is secret mesa and some random number .herokuapp.com. So that's where it would live if we push this. So let's do that. It also adds another remote. Right? Notice this is the origin remote that we added. Right? That's pointing to our GitHub. But when we create, it creates its own repository, its own remote, which points to a repository that's owned by Heroku, git.heroku.com, right? And that's where the source code is going to be pushed so that it can deploy on their remote server, right? So that whatever you push in there is going to compile it, it's going to package it, it's going to deploy it, and it's going to restart the server every time you push. So let's do that. So let's do that. We're going to push into the Heroku. We're going to push the master branch. So it's going to copy all the files to the remote server. It's going to compile it, package it, deploy it, and restart a server based on the type of application. It's downloading all the jar files and all the dependencies and packaging, and it's taking a while. This should occur maybe just the very first time. Right, that's okay, success. It's compiling, deploying, and you should be able to do a Heroku open. It's deployed to Heroku. It's launching the server. There we go. Now we can do a Heroku open, And notice that it says that where it's available, right? Where it made it available. So now it should load the index file. And that's the root URL that we're asking you to submit for this first week. Right? That's a root directory. There it is. So we have our welcome.cs4500, and the hello should be there, and it didn't work. What? Did I misspell it? Did I not merge to master? Oh, I didn't. Okay, all right, let's do that. Right, so you would have created a PR, somebody would have merged it. We can do this ourselves manually. Notice that all our source code went away. We don't have any. We don't have any of our models. We don't have anything. So we can just merge it. We can say git branch in master. We can say git merge hello controller. We're doing it manually ourselves here. But typically you would have gone to a pull request, right? And some other teammate would have merged it for you once they accepted it, right? Once they liked what you did. We're doing it here manually. So let's say git merge hello. Okay, we merged it, and we can push again. We can push to Heroku again. Oh, we can commit. So git status git push. So this is going to push to our Git repository, plus we're going to push to our Heroku master. So it pushes to two repositories. One is the source repository that, as a team, right, we are sharing, and typically you would all be pointing to the same Heroku server, so that any one of you could potentially restart the server, right, and make it compile the server. Usually that's that task is given to one particular person, maybe the project lead or the team lead who's responsible for every week deploying at the end of the sprint. All right, so let's try this again. There it is. There's our hello. Plus, what else do we have here? Objects. There's our object. So whatever we had running locally, now it's running remotely. And we had, what else we had? Parameter, this, it works. Right? Make sense? Everybody good? The other thing that you might want to do is maybe rename this dummy name, that default name, by using Heroku apps rename. So let's do that. Let's rename. Nope, that's not it. Copy, rename, and I'll use the name of the project as my default. There it is, rename. So it gets renamed. Everything good? So we should be able to, it redeploys, so we can say Heroku open. So notice now that the same application I just had running on this Mesa domain, it's now running under CS4500 SP19 S2 JGA. If before the period, if that's longer than 32 characters, it complains, right? This domain can't be longer than so many characters long. So, my username is short enough that I'm not going above that, beyond that. But if your username is too long, you might run into an issue, right? And we'll deal with that. So that's the other part, the deliverable this week. Copy this URL and provide that as your deliverable on Blackboard. Everybody good? Any questions? All right, awesome.